always like this. Okay, perfect. So, good afternoon to everyone. Thank you for being here. Today we have our second session of the MEPHISTO Seminar series on metaphysics and philosophy of science, transcendental orientation. It is a pleasure for me of introducing Professor Michel Bitbol from École normale supérieure, who will be talking to us about transcendental epistemologies and probabilism. Thank you, Michel. The stage is all yours.
Thank you very much, Daniel, for this invitation, and sorry not to be with you physically today. But it will be a pleasure to communicate nevertheless. So, in order to connect transcendental epistemology and probabilism, I think, first of all, to redefine what we should mean by transcendental epistemology in order to fit possibly what, the task of probability. So according to this redefinition, which is based essentially on Kant's and Husserl's acceptations of transcendental epistemology, I would say that transcendental epistemology is one that assumes two things. One, that it is possible to regress from objects to the preconditions for their givenness. So it's essentially the transcendental deduction in Kant's philosophy, and it's the transcendental reduction in Husserl. According to Husserl, transcendental reduction means that you are performing a retrogression, in German Rückgang, from the intentional objects to their condition or to their background in pure consciousness. But the second component of transcendental epistemology, I think, and one which is not always completely spelled out, is that in order to constitute objects out of the background, either conditions of possibility or pure consciousness, you have to anticipate phenomena, both intellectually and practically, through structural assumptions conforming to these preconditions. One component of anticipation is what is called a priori. A priori is a term that is not always well understood. It has a whole history of misunderstandings. The first misunderstanding was that a priori means innate, native. And even Kant was completely averse to that, and he reacted against this interpretation of a priori in his replies to Eberhard. So, but if you understand that a priori means that you anticipate what will come, then it's a better way of understanding it. What the application of a regulative principle, such as the principle of causality, produces, is not an actual order of phenomena, but it is the anticipation of such an order. Here again, it's not very well known, but yet it is very clearly spelled out in Kant's critique of pure reason, in the analytic of principles. And it is this anticipation, rather than the hypothetical order itself, that constitutes the experience of objective occurrences. So, anticipating order is the basic move of transcendental epistemology. Not imposing order, not finding order out there, but anticipating it And it was clearly spelled out by Kant, as I told you. So, for instance, when Kant spoke of the analogies of experience, namely substance, causality, reciprocity, he says that these principles of pure understanding that govern the temporal structure of experience are anticipative principles. According to Kant's own terms, with the analogies of experience, I have a rule for seeking a property or an object in experience and a mark for discovering it there, which means that what is more important than finding the so-called properties or objects, which are not there, which are just, ready to be proposed. The more important and more true than just finding them is seeking them. And the mark for discovering for discovering these objects there is precisely that they conform to the shapes of the principles of pure understanding. So that's the reason why the postulates of empirical thinking in general and the analogies of experience in particular are called regulative principles. This is not, here again, it's very, it's obvious because it's written in the Critique of Pure Reason, but you don't find this very often said and stated very clearly. Even yesterday, when I was looking for something about regulative principles by typing that on ChatGPT desperately said that this is only a feature of reason, and that you can find regulative principles only in the dialectic, in the transcendental dialectic of the Critique of Pure Reason. And yet it is here in the transcendental analytic. So regulative, that means that the analogies of experience are regulative principles, even though they are constitutive of objects. Both are true. So, for instance, according to Kant, it is only under this presupposition, namely, for instance, the presupposition of the law of causality, that the experience of something that happens is possible. So you have to presuppose causality in order to make the experience of objects possible. Here again, you don't have to impose that, you just have to presuppose that. You have to anticipate, the contents of experience, the phenomena. You have to anticipate them with a presupposition like causality, substance, or reciprocity, in order for you to constitute a domain of objectivity. It's the same in Reichenbach's analysis of the special relativity theory, when he spoke about the difference between coordinating principles and other principles. These principles, namely coordinating principles, are provided in advance by us, by our understanding, and even by our instruments. These coordinating principles are what make empirical inquiry possible, and in addition, they are constitutive of a region of objectivity. And I quote Reichenbach here: by determining coordination, these principles define the individual elements of reality, and in this sense, they constitute real objects. But nevertheless, Reichenbach insisted that these coordinating principles that are provided in advance are not necessary in the sense of valid for all time. Unlike Kant, these coordinating principles are not, eternal, and they are not a necessity, an absolute necessity of reason. They are only necessary in a weak, relative sense, namely they are necessary in the sense of conditional necessity, in the sense that they are necessary for a certain practice or orientation of research, but not necessary for all kinds of research. Now, let's come to Husserl and his vision of anticipation. First of all, Husserl made an observation about science. And he said that even the ontic certainty of any straightforward experience is inductive. Things seen are always more than what we really and actually see of them. Seeing and perceiving is having something in advance, vorhaben in German. So, seeing and perceiving is having something in advance. Why? Because you don't see all the objects, you see only the adumbration, and there is an horizon of anticipation. So, in order to perceive, you have to anticipate. You have to have something in advance. This is for perception, but for science, especially for modern Galilean science, you have little more than that. And I must say it was to the dismay of Husserl, because he thought that science should in principle, or ideally, give us much more than just anticipation. And yet, according to him, Galilean science gives us little more than anticipation. Here is what he said in the crisis. We invent a technique, he said, the geometrical and Galilean technique, which is called physics. And what do we actually accomplish through this technique? Nothing but prediction, extended to infinity. So we have, in fact, according to Husserl, it was at the same time an observation and criticism. In science, in modern science, we have only prediction and nothing more, and yet we would like episteme, and episteme is not available in Galilean science. So it's a complaint. The empirical science, he said, speak of reality, formulate hypotheses and laws concerning it, and yet do not investigate that which is ultimately real. Okay, I think that according to Husserl, modern science pretends to speak about reality, but it doesn't. It just anticipates. It just predicts, nothing more. So, and he says exactly that in the following sentence. For their tendency, the tendency of science, of modern science, is directed towards orientation or anticipation in the world rather than towards the innermost exploration of the being of the world. So here again, it's a complaint, it's a critique of science. So Husserl's hope was that the science of physical nature turns into episteme and even into metaphysics, insofar as it is related to the phenomenological doctrine of essences and undergoes a final clarification of science. So according to his hope, according to the hope of Husserl, that he expressed very early in his career, as you say, as you see, it was in 1902. A science can be converted into a true episteme that says the truth about the being of the world if it is connected properly to the phenomenological doctrine of essences. So science plus phenomenology can equal episteme. Now, in quantum physics, we are confronted with a situation in which prediction becomes completely not only predominant but exclusive. We have nothing else than prediction, despite all the claims to the contrary. The reason is that quantum mechanics is essentially probabilistic, and what can probability do other than approximate anticipation and nothing else? And this was, here again, something that was criticized and for which there were complaints, especially from some scientists, such as, for instance, the French mathematician René Thom. He said that a purely probabilistic science suffers from a deficit. It is a deficit of predictability because individual events mostly fall outside the scope of probability. We have only, maybe a collective prediction, but not more. It has a deficit in representation and in description because nothing is represented by probability. Thirdly, there is a deficit of explanation because explanation is usually connected with causation. We have explained an event if we have shown its cause. And the equivalent of causation in a probabilistic framework is very poor. It's much less constraining than ordinary deterministic causation. So apparently there is a deficit of intelligibility due to the probabilistic character of quantum physics. Hence, a long-term preference of many scientists for deterministic and seemingly descriptive formalism as opposed to probabilistic and predictive formalisms. And so that's the reason why René Thom was very horrified, in fact, by quantum physics. He said, it's far and away the intellectual scandal of the century. And someone asked him, what do you mean by scandal? What I mean by this is that science, because of it, has given up the quest for an intelligible world. It really has given up. So we have to answer this critique, of course. So, now come back to the reasons why we should use probability. The usual excuse or reason people gave for using probability is ignorance. And this was the celebrated Laplacian claim. Laplace claimed that we use probability only when we ignore true causes. But then there were more subtle and interesting ways of expressing that. For instance, the way that Henri Poincaré tried, which was that, it's not only that the causes are unknown for just, contingent reasons. It is that the putative causes, if any, because we don't really know whether there are causes or not, but the putative causes might be too small, too complex, and too spread out in space to be exhaustively knowable. So in this case, if they are small, complex, or too distant, then we cannot grasp them easily. And therefore, we ignore them, I would say, for good reasons. Not just because we are too bad to understand causes or to seek causes, but just because they are very difficult to grasp. So this is a serious reason. For instance, when you have, meteorological prediction to elaborate, then the causes of a certain meteorological event can be too small to be grasped. For instance, the so-called or the celebrated butterfly, or they can be too complex, too many molecules of air, and too distant because the causes can be located at the other end of the Earth. But, there is a way to completely turn the tables, to completely do that the other way around. And this was the case of Émile Borel, another French mathematician, who said that, in fact, things are completely reversed with respect to the usual belief of scientists. Namely, it's not that the world is intrinsically deterministic, and due to our ignorance, we cannot go to these deterministic causes, but that, in fact, the world might well be completely stochastic, but due to the large scale of our observations, we have to apply the laws of large numbers. And therefore, due to the law of large numbers, it seems to us that things behave deterministically. And since we see that things seem to be behaving deterministically in the macroscopic environment, then we wrongly deduce that they must be deterministic intrinsically up to the microscopic level. So you see that Émile Borel has completely reverted the reasoning of Henri Poincaré. He tries to adduce the idea that things can be intrinsically stochastic and superficially deterministic instead of the contrary. But this idea of ignorance of true causes can have two varieties. Either it's just because it is difficult to know the little or remote causes, but just difficult. But there can be an ignorance that is not just due to contingency or difficulty, but due to something much more fundamental. And according to Henri Eplan, this is exactly what happens in quantum physics. Our ignorance of causes is not because of contingent, circumstances, but it's because of a necessary impossibility to disentangle ourselves from the causes. And therefore, there are fundamental reasons for which we ignore the causes. And I would add that, in fact, it would be even a little bit exaggerated to say there are causes that, unfortunately, we do not know, because, in fact, since and if the causes are too entangled to us to be distinguished, then on what basis should we say that they exist independently of us? And this is exactly what, in fact, the founders of the theory of probability understood very, very soon. They said something in Latin that I found in Thomas Aquinas, and that's quoted again and again by the founders of theory of probability, such as Blaise Pascal. In Latin, Saint Thomas Aquinas asked, "Quomodo comprehendam ut comprehensus sum?" How could I understand something in which I am included? Okay? When I am included in something, it is quite difficult to disentangle myself from that, and therefore it is difficult to understand it as if it were something given out there independently of me. And for instance, Jan Hacking, who did a wonderful job by retracing the history of probabilistic theories, asked the following things. He asked, he noticed that a condition for the emergence of probability in the 16th and 17th century was the development of sciences of science or secondary qualities. Okay, secondary qualities are relative qualities. They are qualities relative to the organs of senses, our organs of senses. The sciences of first causes, primary qualities, and exact proofs are, for instance, astronomy, geometry, and mechanics, and they don't need, according to him, probabilities. But other sciences, such as medicine or meteorology, needs probability. For instance, according to Girolamo Fracastoro, in the 16th century, the symptoms of a disease in medicine are what he calls signs of probability. And it's one of the first occurrences in history of the word probability. The same for Blaise Pascal, because he said that if we are immersed into the world in incapacity of disentangling ourselves from the world, we are obliged to use probability. But now, in the 20th century, Heisenberg came, of course, created quantum physics, and he said that in quantum physics, even special kinematic variables that were previously considered as direct or primary qualities are now to be considered relative to an instrumental context, and therefore even spatial and kinematic variables are to be treated as if they were secondary qualities. And that's the reason why we should use probability. The same reason as the doctors of the 16th century or the mathematicians of the 17th century. We have to use probability because we cannot disentangle ourselves from the event we want to predict. Now, what about quantum physics? A constant temptation was to emphasize the alleged descriptive status of state vectors beyond their predictive use. Everyone knows that we use psi in order to calculate the probability by using the Bohr's rule. But there has been resistance to accept that, in fact, they are purely probabilistic tools. And only recently, this idea has been put again into favor by doctrines such as cubism, quantum Bayesianism. I will go back to that later. So, but now just see what happened in history. In 1926, Schrödinger insisted that the function psi that he wrote in his equation was in fact a description of a vibration process in the atom, and that this vibration process is close to what one calls reality. Okay, so according to Schrödinger, then psi was a description of a real process. Sorry. In a little bit later, in 1926, Born insisted that in fact a probability is all there is in psi functions, and psi function only give us the probability that a certain path will be followed by the particle. But later you find exactly the same oscillation between a purely probabilistic description of psi and a representationalist acceptation of psi. For instance, David Deutsch in 1985 supported the Everett interpretation of quantum mechanics, and he said that the world is faithfully represented by a unit vector psi, the state, in a Hilbert space H. And still a little bit later, another author can be found who came back to Born's insistence on probability and even radicalized this position. One example is Carlo Rovelli, but I think there are so many other scientists or physicists who nowadays support this position, that the quantum state is nothing more than an accounting of known facts and a tool to predict the probability of unknown facts. End of quote. So we feel that there is an oscillation and a difficulty, a tension in the interpretation of quantum mechanics between two poles, the pole of pure descriptivity and representational value of psi, and the pole of pure predictivity and probabilistic status of psi. And you know that according to Edwin James, this mixture of two acceptation of psi is what he calls a sort of conceptual omelette, which is hard to unscramble. Now, according to the founder of phenomenology, Edmund Husserl, probability tells a lot about the nature of knowledge, and especially physical knowledge. According to him, the use of probability in the theory is a symptom of the replacement of description by prediction, and it is also a mark of the first-person status of knowledge. Okay, so for Husserl, in fact, strangely and interestingly, the discovery of quantum mechanics had been a progress with respect to Galilean science, because finally the scientists, and especially the physicists, became aware of the status of their own knowledge. Even though status of the physical knowledge remains the same, namely pure anticipation, unscrolled to infinity, as he said, even in this case, it is better to know this than not to know it. Okay, but in quantum physics, you know that. You are conscious of that, and you no longer ignore the true status of your knowledge. So, according to Husserl, at the beginning of physics, we invented a particular technique, the geometrical and Galilean technique called physics. What do we actually accomplish through this technique? Nothing but prediction extended to infinity here again. So, but probability is, an implementation, but a clear self-conscious implementation of this nature of physical knowledge. Probability, like calculability, Husserl writes, is a subjective expression that refers to us who make bets and calculate. In the hypothetical nature in itself, there is neither probability nor conjecture. Okay, so it's clear that when in a science you use probability, you are referring to yourself, you are referring back to yourself, because in the hypothetical nature in itself, there is no probability or no conjecture. That can be maybe stochasticity, but stochasticity is another issue. Probabilities, he said, are primarily subjective modifications of judgments which can become objects for new judgments of second order. So it's clear that the interpretation that Husserl favored of probabilities were a subjectivist probability that he probably borrowed from essentially the Bayesian tradition of subjectivist probability. Now, interestingly, even in ordinary perception, you have something that resembles probabilistic inference. In perception, as you know, in the conception of Husserl, a core of actuality, namely the lived presence, the given or presented face of an object, and the halo of inactuality or potentiality are given. So there is a core of actuality and a halo of potentiality. Okay, and of course it is in this halo of potentiality that anticipation, but sometimes non-exact anticipation, usually non-exact anticipation, will take place. And Husserl goes on. The experience of possibility is anticipation and expectation presuming, projection and openness, disappointment and surprise. This is not Husserl, actually. This is Claudia Serban's characterization of Husserl's position. So beyond possibility as conceivability or agreement with logical norms, which is the usual understanding of possibility. For instance, when you read people like David Lewis about possibility and the multiplicity of worlds, this is essentially what he means by possibility. But according to Husserl, possibility is something much more concrete, much more immediate, much more present in perception. It is in a possibility here is a lived sense of a more unfathomable future. We feel possibility even beyond our conceiving it. So, according to Husserl, in a text of 1917 of his Nachlass, what is possible in the sense of probability is the exact correlate of presuming. And just as judging can be correct and incorrect, so presuming can. So there are right and wrong judgments of probability, but probability is nothing else and nothing more than presuming. So here again, it's a very Bayesian conception of probability as subjectivist presumption. Probability was even conceived by Husserl as weighted possibility. Even actuality involves its potentialities, Husserl said, which are not empty possibilities, but rather possibilities intentionally pre-delineated. So that means that the potentialities have a form. They are not completely neutral and open. They have a form, a precise framework, in which you will find fulfillment or no fulfillment. So the potentialities are oriented, just as maybe the intentional ray is. Probability is based on a conviction, says Husserl, which inclines us to formulate a confident conjecture. So here again, probability is a conjecture. And here is again another characterization of Husserl when he speaks of probability. If, apart from judging and as asserting with certainty or considering true, we also consider presuming, considering possible, then what is conscious there is not supposed truth, but supposed probability or possibility. Okay, so presuming implies probability, according to Husserl. Now, so now we have to decide a little bit more about this issue of prediction. So you see that according to Husserl, science, in fact, even Galilean or Newtonian science is little more than prediction. And yet there is this pretension of many scientists to say, oh, well, we have represented reality as it is, or at least we have given, a hypothesis about what reality is. And when the success of our predictions, according to this model of reality we have given, are when the success is clear, then we can say that we may have a good representation of reality. Okay, this is the usual discourse of scientists when they speak with each other. So they would not accept the poor characterization of science that was given by Husserl. And they would say that in this context, quantum physics is an exception. But maybe no. Maybe it's not the case. Maybe Husserl was right. Maybe, in fact, science is essentially prediction, and the models or representations are just ancillary tools for prediction. Maybe. So let's see, recent discussions about this issue. For instance, not very recent, but at least not as old as Galileo. For instance, a very interesting discussion by Heinrich Hertz in his book on mechanics at the end of the 19th century was retained by many philosophers of science as the best possible characterization we can give of what science does. Namely, in Hertz's characterization, science is able not certainly to represent objects with their intrinsic properties, but at least relations between objects, structures. Structural realism was born out of this remark by Hertz. And here is what Hertz said. We form for ourselves images or symbols of external objects, and the form which we give them is such that the necessary consequence of the images in thought are always the images of the necessary consequence in nature of the things pictured. So what is, we have a model, an image, but what is important in that is not the picture of the object, but the picture of the consequence, namely of the relation between an antecedent and a consequent. Okay, but let's read what was written before this celebrated sentence of Heinrich Hertz. According to Heinrich Hertz, the most important problem which our conscious knowledge of nature should enable us to solve is the anticipation of future events, so that we may arrange our present affairs according to such anticipation. In endeavoring thus to draw inferences as to the future from the past, we always adopt the following process, and then he describes the model hypothesis about the nature of science. That science is a model of the relations between objects. But here it clearly appears that this model conception of science is ancillary to the essential task of science, of modern science, which is anticipation. And this was exactly what Bruno De Finetti, creator of the subjectivist, very thorough conception of subjectivist theory of probability, had in mind. For him, probability was not just an idea that was to be used when we have no other ideas, when we are completely short of any capacity of representing or describing the world. In fact, probability is the essence of science, according to him. Here are a few quotes from Bruno De Finetti. He said, nature will not appear to a living being as a monstrous and incorrigibly exact clockwork mechanism, where all is foreseeable if one knows how the mechanism works. To a living science, nature will not be dead but alive, where he means that events always happen, new events that could not even be fathomed, not because we are too weak to do that, but because we are contributing to the creation of these events. And it will be like a friend, namely nature will be like a friend about whom one learned in sweet intimacy how to penetrate the soul and spirit, to know the tastes and inclination. His idea of nature is no longer a clockwork, but a friend with whom we are intimate, with whom we exchange in a way of complete reciprocity. So it's a completely different view of nature that entails a completely different view of knowledge, a view of knowledge that is anticipatory, probabilistic, and no longer descriptive and representational. So I think the new epistemology of probabilism comes very closely associated to a new metaphysics of knowledge. So according to Bruno De Finetti, the laws of nature retain value only as laws of thought for the prediction of natural phenomena. So it's what I was saying also with Heinrich Hertz, because Heinrich Hertz considered that the model was only ancillary to the main task of prediction, that the model was, so to speak, a law of thought, which helped us to predict natural phenomena, and that we mistake for laws of nature. Also, you can think of Bas van Fraassen, who said there are no laws of nature, there are only laws of the model. Another well-known specialist of probability who had this kind of metaphysics of knowledge and therefore this alternative conception of science was Jean Cavaillès, a very remarkable French mathematician and philosopher of mathematics, who wrote a wonderful paper about probability entitled in French Du collectif au pari. Le collectif means, the group knowledge, the knowledge of sets, and the pari means a bet. So in the case of a bet, you bet on individual events and not only on sets of events. So according to Jean Cavaillès, the frequentist interpretation of probability had to be dismissed because, in fact, for reasons that I will not develop because it's really something intricate. But then he adopted the subjectivist interpretation of probabilities, bets on singular events. According to Cavaillès, probabilities are not ancillary, they are not secondary, they are foundational for science. For, he said, there is no measurement that is not based on the theory of error. So whatever attempt you make in order to know something of nature, you will use instruments, you will get outcomes that are given with a certain margin of error. So your knowledge of nature is bound to remain a bet forever. Of course, you can dream of a future asymptotic improvement of these measurements, but as you know, and for fundamental reasons, this is not the case in the realm of quantum physics. But at any rate, Jean Cavaillès said, we have to relinquish the world of sharp-edged certainties to enter the hazy realm of approximations where deeds and bets intertwine. Even confidence that will succeed is a gamble, but the only reasonable gamble. Probability, the blind man's stick, is the only thing that can lead us down the path of the future, if there is a path. So clearly, it's interesting. Deeds and bets intertwine. This is the major, intuition of Jean Cavaillès. In a situation where you cannot disentangle the bets from the deeds that you do in order to either bring out or even produce phenomena, then you are bound to use probabilities. And it's always the case in science. You cannot completely disentangle yourself from the deeds you do in order to know the domain you want to know. So, according to Jean Cavaillès, to know the world is to bet that certain acts will succeed. It's and very interestingly, here again, Cavaillès insists about the reason why we can only bet about the world and not represent it or describe it. He said, it is the law of interest that guides us to insert ourselves into nature, to live within becoming, to invent the movements that will succeed. We have to do that. So this is very crucial. The reason why we use probability is that we don't want, or we cannot, for reasons of principle, distantiate ourselves from nature and see it as if it were an external clockwork, but we have to insert ourselves into nature. And then at the end of the quote, Cavaillé said, even the knowledge value of physical theories appear to be incompatible with the use of probabilities, which is interesting because, you know, at the beginning, Jean Cavaillé said, to know the world is to bet. But then he said, but to bet is not knowledge, you know. Betting is not knowing. So instead of saying that you have a poor mode of knowledge, instead of saying that probabilities are a poor mode of knowledge, you would have to say that probability introduces you to a domain of human understanding in which what is important is not to know the world as if it were completely detached from you, but to cope with the world when you are a part of it. Okay, so I think I will go a little bit further because time is going on. So I will come now to quantum mechanics, and especially to those interpretations of quantum mechanics that have completely accepted this new notion of science as something else than knowledge, but something that is well defined by the use of probabilities, namely coping with something in which you are immersed. And this group of interpretations of quantum mechanics that accept this new mode of understanding the status of science is called the group of Copenhagenish interpretations of quantum mechanics, namely the group of those interpretations that are more or less similar to Bohr's and Heisenberg's interpretations, but that depart from it in certain respects and have some differences between each other. So these Copenhagenish interpretations of quantum mechanics are characterized by 4 features. The first feature and the first assumption of this group of interpretations is that the quantum state is epistemic, namely that it just gives you information, or it is even better doxastic, namely that it expresses beliefs about what will be found when we do experiments. But in any case, it is always probabilistic. Whatever interpretation in the group of Copenhagenish interpretation, they will all say that psi is probabilistic, even though they can hesitate. Is it epistemic or is it doxastic? At any rate, it's not a representation of reality. Second point, it is the so-called relativistic acceptation of facts. It is that understanding that outcomes are unique only for a given observer. Third assumption is that the quantum theory is universal insofar that it applies to every system, whatever its size. But it applies to every system in principle. But part of the measurement chain has to be excluded from its scope from pragmatic reasons. For instance, in Bohr, you find that for reasons of communication with ordinary language, we have to assume that instruments behave as classical objects. The fourth idea is that quantum theory is predictively complete, not descriptively complete, predictively complete. It doesn't need to be supplemented by a hidden variable unless one wants more than predictive completeness and rather seeks descriptive or representational completeness. Now, there are many ways to to analyze and to regroup the various Copenhagenist interpretations of quantum mechanics. So one of them is to separate between the objective and the perspectival interpretations. The interpretations in which facts are unique and objective, and the interpretations in which facts are perspectival or relative to an observer and relative to its experimental setting and to the situation in which this observer is. But there is also another way to distinguish, which is not exactly congruent with the first. It is to separate them between naturalistic and transcendental interpretations. I think that cubism is the archetype of the transcendental interpretation of quantum mechanics, even though it was not imagined this way by the author himself. So what is the difference between a naturalistic and a transcendental interpretation of quantum mechanics? You know that naturalism is a doctrine that says that everything relevant to physics is part of an objective nature, an objectified nature, including the conditions for studying nature. For instance, the subject, the agent, the measuring apparatus should be an object of physical theory and be understood just as part of the physical world. This is the universal naturalization that is typical of the naturalistic approach. And for instance, we find a sentence in which a physicist claims exactly that. He said the projection postulate of standard quantum mechanics relies on measurements. But beware, measurements implicitly suggest anthropocentric notions like measuring devices, which should rather emerge from the theory. So this is also what John Bell said. Measurement is a bad word, and in fact, physics should be a theory of everything, including measuring instruments, and therefore measuring instruments are just objects among many others. But in transcendentalism, it's not the case. The conditions for studying nature are conventionally relegated in the background of nature. They fall under the heading of meta-theory rather than theory. And so, or you can say the conditions for studying nature are precisely conditions of possibility for speaking of a nature, and therefore you cannot claim that they are part of nature, because they are the conditions for us to speak of something called nature. And in many cases, this idea was implemented by physicists. For instance, Einstein in 1905 relegated rulers and clocks in the background preconditions and treated them as meta-theoretical. Bohr in 1927 relegated measuring devices in the background preconditions of quantum theory. And cubism, even more, relegates the agent, her experiences, and so on, in the background preconditions of quantum theory. And a very interesting general statement of this position was given by Mittelstädt in his book of 1998. He said, the measuring apparatuses do not belong to the domain of validity of the object theory, but rather serve to establish a semantics. For this reason, the measuring apparatus fall within the scope of the meta-theory. So there, clearly, transcendentalism accepts that measurement is not a term of the theory, but of the meta-theory. It accepts that agent, experience, consciousness, and so on is just something that a name is in the background and is needed in order to give meaning to whatever is found in our exploration of nature. But this is, as I told you, the case of cubism. Cubism, I will just summarize cubism because many of you certainly know what it is, but at any rate, it's a position according to which the state vectors of quantum mechanics are nothing more than probabilities, and that probabilities are nothing more than a quantitative expression of the tendency to make bets of an agent. Okay, nothing more. So psi expresses nothing of an external world, absolutely nothing, even though Chris Fuchs and other supporters of Cubism would not claim that the world is completely an illusion, of course, but they just claim that psi doesn't represent anything like an external world. And Cubism insists that agent is a primitive, and even more primitive than agent is, as in this quote above, the concept of experience, the lived experience of agents. According to Cubism, quantum mechanics is a theory that any agent can use to evaluate his expectations for the content of his personal experience. So it's all about experience, okay? And even psi is about experience, even before you have the experience of an outcome, because a quantum state is an agent's personal judgment. You can have an experience of your personal judgment. Okay? But the Born rule, which is a normative constraint on an agent's probability assignments, a normative constraint on the bets an agent makes in order to anticipate the outcomes of experiments, you know, it's a norm. So since it's a norm, where does it come from? To a certain extent, it comes from conditions of self-consistency of the system of probabilistic predictions. But it's not enough, because there are several types of self-consistent system of predictions. For instance, there is a Kolmogorov set, and there is the non-Kolmogorovian set, such as the quantum theoretical set of predictions. So there must be something else. There must be something else that imposes a mark on the normative constraints that is imposed on us by the Born rule. And according to the founders of Cubism, this is precisely there that the imprint of something that overcomes us, of something that transcends us, and that we call the external world, but in fact we should not call the external world, because it's not completely external to us, it is in complete continuity with us. It is precisely that is the mark of this transcendence. Okay, so this is why Cubists so much insisted on a concept that they borrowed from John Wheeler, namely the observer participancy. The idea that observers are not onlookers of nature, but they are participants, and this is the precise reason why they cannot do otherwise than use probabilities. One possibility to make sense of this very special situation in which we are with respect to the world, namely as participants, is to borrow a concept, an ontological concept developed by Maurice Merleau-Ponty, in order to make sense of, I would say, the ontology of our own body. When we speak of our own body, it's a very special entity, actually. It's an entity from which we cannot be separate. It's an entity with which we are in complete continuity. We cannot say that we observe our body only to a very limited extent. To a much larger extent, we are our body. So we are our body and we observe our body at different times. I would say we observe parts of our body by the fact that we are our body, and therefore we have an experience that is completely coextensive to this body. So in order to cope with this very situation of the own body, Merleau-Ponty elaborated the concept of what he calls an endo-ontology, namely an ontology according to which we are so closely intertwined with nature, so woven into it, in the midst of it, just as we are very woven into our body, that we cannot observe it entirely as if its processes were unfolding on the stage out there in front of us. So if you apply this very special situation in which we are within our body to the world as a whole, then you have a good model for an ontology of the world as conceived by a purely probabilistic and highly participatory science. And I think this is the ultimate teaching, in fact, of a transcendental approach. Thank you very much.
Thank you very much, Michel, for this very dense talk. Now we will have 5 minutes break, and then we will be back to the discussion.
We will check if the microphone is okay for asking questions. So 5-minute breaks.
Yes.
Yeah.
Can you hear us? Can you hear us well, Michel?
Perfect, perfect.
Oh, great. So 5 minutes.
Yes. See you.
Get back with questions.
Thank you.
Yes. Reviens sur ton truc des jeux végétariennes. Pourquoi tu as besoin de métaphysiquement fonder les objets manipulés par les praticiens en médecine?
Mais
Si tu peux juste les assumer, s'ils utilisent des trucs, par exemple, si les généticiens, ils trahissent ce qu'on appelle un gène, ils ont des expressions de ce que c'est qui est différent. C'est pas tout à fait clair qu'est-ce qu'ils utilisent, mais on met pas en question ou non le fait qu'ils utilisent cet élément-là. On n'a pas besoin de le fonder fortement. On peut juste dire ils l'utilisent, donc on va l'étudier comme tout, on va le postuler comme étant une entité pertinente dans leur appareillage théorique. C'est avec lequel ils fonctionnent. C'est un peu comme l'argument contre les arguments contextualistes contre le sceptique radical, c'est que si le fait qu'on soit en train de discuter puis qu'on échange, on a certains éléments qu'on doit postuler pour fonctionner. Si le monde n'existe pas, si par exemple les lois changent continuellement, on parle, mais on ne pourrait même pas communiquer un peu dans les préconditions.
c'est vrai qu'on n'a pas forcément besoin. C'est juste que j'avais un... Non, mais j'avais un débat par rapport au fait que c'est des entités qui sont vagues, genre les maladies. Et donc la question c'était, enfin, on a eu une discussion avec Peter sur est-ce que c'est genre des entités linguistiques ou des entités ontologiques, et c'est ça. Et fort d'affirmer que c'était genre ontologiquement ça existe et c'est ontologiquement vague, etc. Et que donc c'est peut-être une même ça. Les entités linguistiques, ça me semble un peu faible par rapport à l'utilisation que vous faites des notions de maladie, etc. Mais
il y a certains trucs qui sont plus existants que d'autres, ou qui sont gardés par ton argument. Tu veux dire, il y a des éléments qu'on garde vraiment plus flexibles dans le fait, mais faire plus que ça, à moins que ça serve dans l'argument quelque part d'autre.
peut-être pas nécessaire, ouais.
À moins que tu essaies de dire, bon, il est différent. Tandine va se dire, il focalise encore beaucoup. Là.
Ah oui, là, mais j'ai plus compris que ça.
C'est très clair, hein? Non, mais c'est très clair.
Et il y avait des rêves, des trucs que je vais en cours au final. Plus de choses que je vais en cours que dans certaines autres temps. Ah ouais, il y avait des grilles un peu partout, donc je ne décourage pas.
Est-ce que tu peux avoir des entités dans ton quotidien qui sont aussi différentes dans un trafic? Si on postule que ça existe, si on fait l'environnement du sport, et une commande. C'est quelle heure? You're leading. We're deciding when you start. Yes. So when is that? When? When? Yeah, because for me, it's actually already. Cherche mes cafés. Okay, perfect.
I heard that everyone is speaking French in this room.
I think when, except when and then Yale.
Okay, so if you want to speak French, please do. It's even easier.
Okay, so I think we can start with questions, comments. Please.
Yes, it's more of a sort of understanding and clarification question. So you began your presentation with introducing the role of anticipation in transcendental projects of both Kant and Husserl. And then you went on in the second half to talk more about the role, the transcendental interpretation of probabilism, specifically in quantum mechanics. And I just wanted to ask you, what's the connection between the anticipation as something which constitutes objects and anticipation if we just start from if we start with physics and just from the beginning we just say, oh, it's just prediction, it's only about predicting the something. Do you want to say that in fact this is the same sort of type of anticipation? So if this will involve that we can objectify in the sense the quantum mechanics or not?
Yes, I think so. In fact, the basis for objectification is anticipation. Anticipation under a certain rule or form. We can anticipate future events about what we will find according to the form that we give to the object. For instance, we can predict that we will see a certain planet at a certain point. But the form of this anticipation is conform to the concept that there is a single object going from one point to another point of the trajectory. Now, some of our anticipations, especially I must say in quantum physics, are such that their order is no longer easily assimilated by the ordinary concept of a spatiotemporal object. And in this case, we have troubles with ontology. But ontology should not be understood as given in advance, given out there. It is precisely the form with which we anticipate a group of events. If this form is no longer fulfilled, then we can have many doubts about the type of objects we are exploring. Okay, so you are right. There is a continuity between the two types of anticipations.
Okay, thank you. Questions? Alexandre?
Thank you, Michel, for this very clear thought. I still have difficulties, but it's an old problem since I'm reading you for decades now. To understand the normativity in the transcendental, the normativity of the Born rule in the transcendental approach in general, Because for me, it's much easier to see how this normativity is coming from in the many worlds interpretation, where I say, okay, there's no real probability in the many world. It's purely subjective. I have some Dutch argument or Wallace argument why the Born rule is the good rule. But it's much more mysterious to me where the Born rule is coming from in the transcendental approach. It's a brute fact coming from the world, or how does it work?
There are several possible approaches of the Born rule in the transcendental interpretation. There are some derivations of the Born rule that come from very elementary principles that you could consider as transcendental principles. For instance, there is the Gleason theorem, there is the derivation of Jean-Louis Détouche and Paulette Détouche-Février, that all come from very elementary principles, such as just, two principles, in fact. The principle of additivity of probabilities to 1. So the simple fact that the set of Born's coefficient should add to 1, first condition, and second, that the instrument for generating sets of probabilities that correspond to each observable should be unique. So if you positive these two conditions, probabilistic nature of prediction 1, and 2, unity of the tool of prediction, then you generate automatically Born's rule, which is quite interesting, because that means that it can be derived from first principles. Another approach, interpretation, is the one that was elaborated by Chris Fuchs, and which is, I think, much more subtle and much more careful. He says that the Born's rule can be derived from two sources. The first source is the Dutch book theorem, the Dutch book condition, coherence of bets in order for you not to lose your money each time you bet. But there appears a certain coefficient, which is the coefficient 2, which cannot be justified on this basis. And therefore, according to them, it's not really, it's not really my approach, but it's theirs. It's really the cubist view. Is that this coefficient 2 precisely must be imposed by something that is not just the conditions of possibility of knowledge, but something that comes from a constraint that is transcendent to us. I don't say external, because external, it means like it sounds like as if it were two separated things in space. But I prefer to say transcendent to us insofar that we do not entirely master it. So this is another idea, and I think it's not averse to the first approach I've spoken to you, I've explained to you, because in the first approach, the fact that in the Born rule appears the square instead of any other power can be justified, but there is a little empirical input into the justification of this factor 2 of the square in the Born rule. So clearly there is a dose of contingency that must be, a mark of something which we do not master, and which is not only, which doesn't belong only to us, but in no transcendental view of knowledge you can completely escape this conclusion. Neither in Kant, with his concept of thing in itself, nor in Husserl, because there is this, this sense of transcendence in immanence, which is also a sense of otherness.
Okay. Can I? Yes, sure. So, okay. So I like your answer, because sometimes if you rely on too much on these proof, you will maybe ontologize the notion of information or reason or something like that, which is tricky for me in the transcendental approach. Because, for example, based on the Dutch book, there's a long discussion on the Dutch book argument about, is it a constraint of reason? Is it a constraint of just betting? Is it a constraint? Where does constraint come from? And Van Trazen was arguing that it's a constraint of reason, but it's not obvious to me what does it mean. But if you say, okay, we have these proofs, but they have their limits, and ultimately the world is what it is, I think it's a better answer, maybe, or at least more modest than to find a priori the rules of reason.
Yeah, of course, yes.
Yeah.
Yes, I think, but in any transcendental conception of knowledge, you have to balance between what is provided by our reason in advance and what our reason must accept. And I think that if you dig well into all of, in all literature about transcendental philosophy, you always find the two things. The only thing that, and I agree with this component also of the transcendental thought, is that the contingent part of knowledge is amazingly small. It can be located in a very, very little compartment of knowledge, and this is the best possible game of physical science, is to show how much is due to reason and how little to empirical contingency. But little is not nothing. As Kant would have said, it's not because the dove likes thin air that it can fly in pure vacuum.
Thank you. Other questions? Yes, Gary.
Yeah, thank you, Michel, for the talk. Super great. So it's a naive question. I'm not familiar with those debates, but I just want to hear you a little bit more about the relationship between possibility and probability. So when you mentioned there's an equivalence for Husserl on those two notions, but it seems that I don't find good counterexample for one side of the argument, but for at least the other one, it seems that certain account of possibility are wider than, for example, some account of probability in science. I would say you have two levels. So, for example, it's easy to me to see how I could say that the existence of God is possible if I have a concept of possibility from logic, model logic. So, there's a world where God exists, but for scientific conception of probability, or its use in science, if you prefer, I don't see how I would qualify on a numeric scale, for example, the probability that God exists. It seems that we don't have the tool to check those kind of accounts. I do wonder, so for Husserl, it seems like those two notions hang in a certain way, like at the right level, so both of them are equivalent from each other. But I do wonder, especially since you expand on your with example from quantum mechanics, I do wonder if those concepts do hold at the same place. So is possibility the same thing that we shall have in mind, for example, or probability, or how those concepts relate one to each other? Is it stronger sense of possibility compared to probability? So I just want to hear you a little bit more and dig a little bit more about what at least, since it's your example, what concept people are using to see if it's the right level for them to have a strong equivalence in a certain way.
Yes, this is an interesting and difficult question, but I think I tried to make clear that Husserl doesn't think that the probability is associated to possibility in the case in which there are only rational possibilities or logical possibilities. For instance, I think the logical possibilities are that there is God or there is not God is not it's not a possibility in the sense that was privileged by Husserl, namely a sense in which possibility is almost a direct experience of anticipating what could be in the next step, that what you could perhaps observe in the next step of a perception. Because there is no beginning to an anticipation of some entities like God or the infinite and so on. There is no beginning. There is no nucleus of the perception. There is no present no initial presentation. While in perception you have the initial presentation and you have the possible presentations. The initial presentation is a motivation to think, not only to think, to feel that there will be other possibilities in the future. So it is only to this kind of lived possibility, lived and experienced possibility, just beyond the nucleus of immediate apprehension, that Husserl applied the concept of probability. Probability is the more or less intense opinion or even feeling that something could happen. If there is no initial feeling and no possibility of fulfilling it, then there is no sense in which you can ascribe a probability. So I think you should distinguish between the abstract possibility for which probability hardly apply in the sense of phenomenology, and the strongly embodied perceptive possibility to which the concept of probability can apply according to Husserl, because probability is just, as in every subjectivist interpretation, just a tendency to bet or to anticipate.
Okay. Other questions? Again, a good question of clarification. You introduce Reichenbach coordinating principles at the beginning, but it seems that Reichenbach is much less constraining than everything that follows. So maybe I missed why did you introduce Reichenbach?
Reichenbach is just because I wanted to give an example of a constitutive a priori, which is not necessary and not and clearly not innate. But of course, even Kant is not innate. Even Kant's a priori is not innate. But in Reichenbach, it's absolutely clear. There is no ambiguity on that. And he even claims that an a priori is not necessary, according to him. So, and the idea was to adduce the concept of an anticipation that can be necessary to a certain range of epistemic activities, but is not necessary full stop. So this is, I think, this is a middle way between a strong a priori belonging to the nature of reason on the one hand, and something much weaker, such as a convention, the convention of conventionalism. In between this a priori as a fact, an absolute fact of reason, and convention as a very relative, very flexible kind of anticipated knowledge, you have this notion of coordinating principle that was formulated by Reichenbach. So I think it was this idea that I wanted to emphasize.
So I was curious. So in your transcendental approach, where you have these conditional necessity that you try to capture, what is the status of mathematics? Because we cannot do quantum mechanics without mathematics. So mathematics must have a certain status. And I know that Daniele is really interested by the status of transcendental status of mathematics. So I'm asking the question before him.
Yes. Well, I think mathematics could enter quite well into this middle way between absolute necessity of reason and completely contingent convention, even though Poincaré very much advocated the conventional status of it. But mathematics conveys a form of necessity, which is an internal necessity, given a certain number of premises. So this is a form of a very extremely strong form of necessity, but not an absolute one. And the use of mathematics in physics, obviously, is probably, I make a hypothesis here, is probably connected with the common origin of the two practices, which is precisely an origin in praxis, in action, in measurement, in all these activities of, providing gestures that coordinate with each other and give some quantitative values. So this is the common origin of the two disciplines, physics and mathematics, and probably it's one of the reasons why they cope so well together.
Thank you.
I have a question from Julian, who asks, second. Yes, he asks, what about the no miracle argument for scientific realism? How do you explain the predictive success of theories, even if probabilistic in nature? Can you do that in your transcendental approach, or is it totally orthogonal to it?
Yes, of course. The famous no miracle argument says that it would be a miracle if science works so well if it didn't represent the world. Of course, this is a very, very frequent question. And my usual answer is just to ask someone who asks this question, okay, look, a mouse have a lot of success in its survival in a certain environment. Does it mean that the mouse resembles the rooms in which they move or the woods in which they find their food? Obviously not. There is no form of resemblance here. It is adaptation. And I think the conception of knowledge that fits better the probabilistic status of science is precisely one of adaptation. But, the difference between biological adaptation and scientific adaptation is that science has found the general rules that make possible any adaptation. And in this sense, it has a transcendental component, because it's not just a contingent adaptation, it's internally necessary adaptation. If you use the rules of quantum mechanics, you will automatically be adapted, because these rules of quantum mechanics extract the elementary conditions of purposability of a huge class of situations of coping with your environment. So it's, I think, so the reason of the success of science is this one: coordinating all the possibilities for successful adaptation. That's it. Just as, for instance, the Dutch book is not, the Dutch book seems to be a completely abstract rule, but if you transgress it, then you will automatically lose your bets. So this rule is not something that is found out there, but it's a condition of inner consistence of the system of bets. The same for the system of our science.
Okay, Julian answered already. Yes. 1 second. Okay, he thanks you for your answer, and he says that this seems a naturalistic explanation insofar as science is taken as part of nature and its success explained in terms of adaptation.
So he agrees.
Yes. Yes. And yeah, do we have other questions?
Yes, fine. So if you want to ask your questions, you're waiting for us.
No, the two that you already asked, because the first one was that on the empirical or transcendental role of for review, and then the last one on mathematics. I have some more, but if somebody has other questions, I give them reference.
Then go.
So, yeah, first of all, a small follow-up on Julien's question. So can we say that this adaptation you are talking about comes in some way from the fact that the instruments we use in doing quantum mechanics, like math, are actually a priori conditions in a transcendental sense of this scientific practice?
What is a priori is the condition of consistency, in fact. The condition of consistency is something that we adduce, and therefore we do all our bets according to this condition of coherence, that from which you can generate the structure of the theory of probability. All the rest is open to contingency, to empirical contingency.
Thank you. And the second question is this one. Do you think that the primitiveness of subject in cubism is compatible with a phenomenological perspective like the one you have been outlining? I mean, is the transcendental nature of subjectivity as conceived in cubism compatible with?
The way, of course, cubism conceives what it calls the experience of the agent. There is nothing more in cubism than this expression: experience and agent, nothing more. All the rest is Husserlian. If you speak of pure consciousness, of transcendental ego, and so on, this is not the vocabulary of cubism. But if you think seriously about what cubists say, you will find that there is not only a compatibility, but even a continuity between a phenomenological approach and an approach of science that is analogous to cubism. There is a continuity because, in Cubism, what is implied is not only an experiencing agent, but also an embodied agent, very similar to Merleau-Ponty's. Each time they are pressed to make precise their conception of situated knowledge, implying an agent, they come closer and closer to the phenomenological descriptions of it. So, for instance, they have done that when they treated the Wigner paradox. The Wigner paradox can only be solved from their standpoint if they imply an embodied experiencing agent. So I think that there is a lot of compatibility and community between the two spheres of thinking, and my work is to establish even more this continuity, and presently I'm finishing a book about that.
Thank you. Thank you very much. Yes, Ken.
Yeah, thanks again, Michel. So one thing that caught my attention during your talk is when you talk about the link between prediction and science. And for me, at least from a philosopher of science perspective from the exterior, it seems to me that there was a switch there. We first started more on like the limit of how do we construct knowledge in a certain sense, saying like we always stop working with prediction. And then you started to talk about what are the general aim in science, and that's where you mentioned those Hertz and Finetti and Cavaliers. It just here for me, it seems, at least it's clear for me that there's two levels of discussion that are different. And when I was following you there, and then you end up in quantum mechanics, at least for a philosopher of biology, it's since the inner working is so different in some field in biology and how quantum mechanics is working, it seems for me that there were, for example, all the frequencies account of probability wasn't present in what you were mentioning. So I wasn't sure exactly where was your more general argument, where you're saying like, okay, so if we build on the limit of our knowledge and we're stuck with only prediction on prediction, and if we go with Husserl, then it's only subjective account of probability that is the right one. I mean, for the reconstructing what scientists is doing in other field of science, it seems the historical support, or at least your example, won't be as easy to provide, I would say. So I just want to hear you more about those two things. Like, what exactly that switch that you made from what I call limit to what we know, and then the importance of prediction in science, and then just to hear you more also, is your claim more general than for quantum mechanics? And if it's the case, like, do you have, like, how does that account for like mechanistic explanation or functional explanation that are super widely used in biology? So I just want to hear you more about this kind of topic.
Yes, in fact, I think the articulation between the two parts that you mentioned was given by my slide on Heinrich Hertz, because you can have a conception of knowledge in which the model is supposed to represent reality, but unfortunately you don't know enough of reality to completely fill the gaps of the model, and therefore you use probability. This is the first idea. But the second idea that was made clear by the articulation of the two sentences of Heinrich Hertz was that it's rather the other way around, namely that the basis of knowledge, the basis of science, in fact, is anticipation. Anticipation, in general, is formulated in terms of probabilities, but in order to shape correctly your anticipation and even your probabilistic anticipation, you need, I would say, a mental model. The mental model is no longer a representation of the world, but it's a representation that you use in order to best formulate your predictions. So it's an ancillary model. And Erwin Schrödinger, who was keen on representations, who was supposed to be realist in science, at the end of his career, he had exactly this idea. He said, we provide a representation, but this representation, we don't claim that it is a representation of the world. It's a representation for us, because we need representation in order to cope best with the task of predicting. So in that case, the hierarchy between description and prediction is reverted. Usually you have description on top and prediction that is derived from it, and even that can be derived in a poor way when you have to use only probabilities because of your lack of knowledge of what the model describes, and so on and so on. But now you can turn everything upside down and say probability is the principle of science, because it is the expression of our deep entanglement with the world that we explore. And therefore, models or so-called representations or so-called descriptions are nothing more than just tools, mental tools, and certainly not to be taken as a sort of dream of perfection of knowledge that we wanted to reach, but unfortunately we don't reach. This is I think that in my talk there was this movement in which one can start from the representationalist and the modelizing view of science, and then go to the purely predictive conception of science, which is no longer to be taken as a sort of inferior variety, but rather as the essence or the norm.
Thanks. Okay. Any other question? Yes, is up.
Yeah, it's sort of a little bit of a follow-up on the previous question. So I was just curious that you mentioned the challenges raised to this purely predictive probabilistic vision, and one of them was when you quoted René on causality and explanation.
Yeah.
That if you want science to be descriptive, then you will say prediction is sort of not enough if you want to actually explain. And I was just curious, what would be this distinction between something causal and non-causal, or will there be something like this in transcendental sort of view?
Yeah, well, explanation is a problem, but first of all, I would say this is not reason enough to say that the purely predictive view of science is wrong. That we miss an explanation is not a good reason to dismiss the predictive conception. But now, when I see in practice what scientists do in the laboratories, they use two types of tools in order to give explanations in spite of what they might accept as a purely probabilistic and predictive view of quantum physics, for instance. First of all, they have this what I called ancillary models. They always have in their mind, for instance, a wave-like model or a particle-like model or whatsoever. Even though none of this model is correct in isolation, and moreover, none of this model can be coherently combined with other models to give a complete descriptive theory, they are very useful as mental tools to give something that can be taken as an explanation in an ordinary audience or even in a scientific audience. The second point is that, you know, in the history of science, and especially the history of physics, the meaning of the concept of explanation has changed a lot. When you go from Aristotle to quantum mechanics, you find that at least 4 steps were crossed in our understanding of what an explanation is and should provide us. You know, for instance, in Aristotelian terms, you can explain something only if you connect that to the essence of things, to the substantial forms, as they said, you know. Or in the Cartesian context, you would say, oh, in order to give an explanation, you just have to see the processes in terms of mechanical kicks, you know, one particle that kicks another and changes its direction, and this is a mechanistic explanation. I think usually people are still at this stage, you know, even physicists love mechanistic explanations. But then Newton came, and another type of explanation has emerged that was called by Hempel the deductive nomological explanation. Namely, something is explained by showing that there was an antecedent that is connected to that by a law. And this is not a mechanistic explanation any longer. And yet, I think for some time it has been taken as a satisfactory explanation. And then came quantum mechanics, in which you cannot give this kind of mechanistic, nor even nomological explanation. And you can have a probabilistic nomological explanation, because you can say, okay, even though I cannot explain that event by a single cause, I can explain the connection of this event with former causes in the plural by way of a certain equation that is the Schrödinger equation. So, but the Schrödinger equations connects probabilities, not events. So there you can have a deductive nomological probabilistic explanation that is taken as satisfactory by many people, even though it doesn't resemble other past types of explanation. So explanation is I would say a moving target. It's evolving in the history, and the fact that we have changed our conception of explanation is not a mark of our failure, I would say.
Okay, thank you.
Okay, thank you very much, Michel. Thank you, everyone.
Thank you for your virtual hospitality.
Thank you very much, Michel.
Thank you again, and I think we can call it a day.
Here, Tom.
Thank you. Bye-bye. Bye.
Thank you. Bye.